Okay, so today we're going to be looking at the ambiguous case for using the law of cosines. And the ambiguous case you might remember from geometry as being the side-side angle, or the ASS case. And one thing that you might notice that these problems are a little bit more involved, so they're a little bit more difficult. So you could remember this as they're a little bit of a pain in the ASS. So we're going to start with our problems the same way that we start with everything. We're going to draw and label our diagram. So on this one, we're given the angle X, but then we're also given its opposite side and one other side. So it's a little bit hard to start off. So to make an accurate diagram, usually start with the angle. So here's an angle measure 27 degrees. And so what you can do is, we know that the side length y, and I usually start with that one on the horizontal, is set. It's fixed at 5. We also know that side length x, which is going to be across from 27, is fixed at 6. We just don't know what the angle in here, w, is. So we could play around with it a little. We could make it really, really obtuse. We could make it acute. So we can start with this diagram. And so we've got our 27 degrees x, and of course you're labeling all 9 pieces of information, each side letter with lowercase, each angle letter with uppercase, and the 3 pieces of information that you're given. So because we're only given one angle, that means that we need to use the law of cosines. So we're going to set up our law of cosines looking for the angle x, 27. So go ahead and write the formula with just letters for the law of cosines, given that we're looking for angle x. So now we can go ahead and plug in the information that we're given, and you'll notice that now we're plugging in out here for the isolated squared variable, which normally that remains a variable. And so this is one of the main reasons I make you write the formula with just letters, because if you write it out and then you look at substituting in, you'll make a lot fewer mistakes. So we can still solve this, but we've got w in a couple of places. So we've got a w squared, we have a not squared w, and then we have some constants. So this might be reminding you of a quadratic equation. And so what we're going to do to solve our quadratic equation is we need to find our a, our b, and our c. So a is 1, c is negative 11, but b is going to be this negative 10 cosine 27. So put that entire thing into your calculator. Negative 10 cosine 27. Don't forget the negative. Okay, so you should get negative 8.91 and then store that. Make sure that you're using your stored values. Don't hand type anything into your calculator once you've calculated. All right, so now we know our a, our b, and our c. So we're going to use the quadratic formula. So just be really careful when you're calculating this. Make sure that you're using appropriate parentheses and setting it up in your calculator. You're going to have to do it 2 separate times, once for plus and then once for minus. Now remember that you can do second enter to recall what you've just typed in, and then all you have to do is switch the plus to a minus. You don't have to hand type everything in all over again. So pause the video while you calculate and then compare your answers to what I get. Okay, so once you've calculated, you should get 2 values, one 10.01 and the other negative 1.10. And the reason I've crossed this one out is because it's a negative. And remember, we're looking at a length here. And so even though on the coordinate plane we could have negative side lengths of triangles, this is an actual triangle, so we can't have a negative length. So that one is going to say not a triangle. So the only answer we're going to use is the 10.01. What's happening with the negative 1 is, remember, I circled this around, so the negative 1 is actually out here. So it still uses all of the information, it's just kind of rotating backwards, so it doesn't really exist as a triangle. So the only triangle that exists is this one that we started with. Okay, so now we're still solving the triangle. Now we have all 3 side lengths, we still have one angle, but we can find everything else given that information. So we can find any of the other angles using the law of cosines, and then whichever one we don't find with the law of cosines, just subtract off from 180. So I found w first. It really doesn't matter which one you find. Of course, you're still writing in your formula with letters and then with numbers. So go ahead and pause the video so that you can do the entire rest of the problem. Once you're done, check back in, check your answers, and see how you did. Okay, so you should have gotten 130.77 degrees for angle W. You can check against your diagram, and that's an obtuse angle, so that makes sense. And then subtracting, you should have gotten 22.23 degrees for angle Y, and again, that's a little angle, so that makes sense as well. Okay, so with the ambiguous case, the reason it's called the ambiguous case is because it's unclear what type of triangle that we're going to have. It's unclear here whether we were going to have one triangle, two triangles, or no triangles. And you could have any of those scenarios.